So we are jumping to chapter 7. This is video number 1 on exponents, but of course on your notebook, you probably don't want to write video number 1. You want to write down notes 7.1. So notes 7.1, exponents. And in this section of our book, we're going to end up going over the first 3 rules of exponents. Now there's about 7 total, but 2 of them could kind of be meshed together. But we're going to go over 3 rules today, and then more rules tomorrow, and so on and so on. Eventually this whole week we'll get through all 7 rules of exponents. So before we even get to the rules, we need to start understanding what an exponent is. And in your notes, I would like you to please write down b, and then with the power of p, okay? And then we're going to take down these notes that the b value is going to be the base. B is the base, obviously. And the p is going to be the exponent, also known a.k.a. power. You guys with me?
Yes.
All right. So copy that down. Also copy this down. The p, or you could write the power, tells you how many times to multiply the base with itself. Okay? Once again, let me repeat that. The power tells you how many times to multiply the base with itself. So here's an example. We're going to go 2 to the 3rd power. Okay? So once again, what's the base? 2. What's the power? 3. Or you could also call it the exponent. Now once again, the power tells you how many times to multiply the b, the base, with itself. So this 3 is really telling you how many times to multiply the base with itself. I know some of us already know this stuff, but what it's really saying, and I'm going to write equals because this is what it's really saying, 2 to the 3rd really says 2 times 2 times 2. So 2 times 2 is 4, and 4 times 2 is 8. So 2 to the 3rd is really 8. Make sense? Now, you don't actually have to write this. You know, I say show your work. You know, once you understand this, you don't have to write this 2 times 2 times 2. This is actually called expanding. Okay, and expanding does come in handy when we're trying to understand the rules that we're going to be learning of exponents. So you don't have to show this expansion, but you do need to know that the 3 tells you how many times to multiply 2 with itself. So 2 times 2 times 2, the answer is 8. So with that rationale, what would 3 to the 3rd power be? Now, 9 is the most common wrong answer.
No, I got it. 9 because... Oh, no. You do 3 times 3, and then that's 9. And then you do 3 times 3.
Okay.
So it's like 9 times 3, 27.
So at the beginning, if you're confused, the expanding would be good. 3 times 3 is 9. 9 times 3 is 27. So 3 to the 3rd is 27. So let me rearrange this, make more space. So check this out, guys. Parentheses make a huge difference. Okay, parentheses make a huge difference. Now, what do I mean by that? That parentheses make a huge difference. What is 2 to the 2nd power? 4, because when you expand it, you have 2 times 2, and you get 4. Now, what if I put negative 2 to the 2nd power? What's the answer there? Right here, it's actually, a lot of people say 4, but it's actually negative 4, right? Now, the reason for that is, in order for us to really understand this one, let me get this out, let me do this over. How about this? Let me put 2 to the negative 2 to the 2, and let me compare it with parenthesis negative 2 to the 2. There is a big difference when you have parentheses. Parentheses make a big difference, okay? This bottom one really does say negative 2 to the 2nd power. Okay, so when you expand it, it really does say negative 2 times negative 2, and that really is positive 4. Are you with me? Now, the top one, it doesn't have parentheses around the negative 2. There are no parentheses. Like right here, there's parentheses. Up here, there's no parentheses. So what does that really mean? That you need to do the exponent first, the 2 squared. You need to do that first. 2 squared is really 2 times 2. Now, this negative sign that's in front, you just put that right in front of your expansion. So this problem really becomes negative 2 times positive 2, and the answer is negative 4. So the parentheses really do make a difference. You see, the parentheses, what they end up doing is they include the minus sign that's inside. So this truly does say negative 2 times negative 2. Now up here, there are no parentheses, so it's not including the negative sign. So up here, it just says 2 squared, and when you get your answer, you put a negative in front of it.
Exponents.
Yeah, so Eddie, if you have negative 3 to the second power, what's your answer going to be?
It's going to be negative 9.
Negative 9. Good job. Now, why is that? Because you take the 3 squared first, and you go 3 times 3, and then you take that minus sign, you put it in front. So that's really a negative 3 times 3, which is negative 9. As opposed to if I had negative 3 in parentheses to the power of 2, then when you expand it, it becomes negative 3 times negative 3, which that one really is positive 9. Do we understand the difference that those parentheses make? All right, good. Let's actually move on now to our first rule of exponents. Copy this rule down in your notebooks. This is rule number 1. The rule says if you are multiplying 2 terms with the same base, add the exponents and keep the base. So right here we have x squared times x to the third, and they obviously have the same base. This base is x, this base is x. They truly are multiplying. I'm going to put a little dot between them. You don't have to. When there is no sign between it, we know they're multiplying. So right here we have this situation where we're multiplying 2 terms with the same base, and what we need to do is add the exponents. So the answer would be x to the 5th. Now the explanation why we're able to add exponents when we're multiplying and we have the same base is, let's actually expand. What does x squared actually mean? X squared actually means x times x, right? X to the third actually means x times x times x. And of course, there's a multiplication between both the x times x and the x times x times x. And of course, your answer is x to the 5th. But you don't have to show all this work. I just wanted to explain where this rule came from. It's not like some dude just said, you know what, let's add 2 plus 3 and get 5. We're going to call that a rule. It doesn't come from there. It comes from this truth that x squared is really x times x. X to the third is really x times x times x. So the rule is actually a shortcut. Instead of doing all this work, you could just add 2 plus 3 and get 5. Excellent question. So is it with variables or could it be with numbers as well? It could be with numbers as well. So if you do have 2 to the second times 2 to the third, that really becomes 2 to the 5th because 2 plus 3 is 5. Now, whenever you do have a situation like this, 2 to the 5th, and you could actually simplify it, you might as well simplify it. So you'd actually have to go, okay, 2 times 2 times 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. So it'd always be a good idea to expand it. And of course, you could use your calculators to expand it. I mean, not to expand it, but to get the final answers, final simplified answer. Unless they tell you leave it in exponential form. If they tell you leave it in exponential form, then 2 to the 5th is good enough. Okay? But yes, the rule does apply if you have numbers as a base as opposed to variables. Now remember, it has to be the same base. So x to the second times y to the third, you can't do that. You would just leave it x squared y to the third, or x squared y cubed. You just rewrite it. But if you had x to the second times y to the third times x to the fourth, then you could actually multiply the x's together. If you want, you could rearrange it and say x squared times x to the fourth, and then put the y to the third at the end. That's fine. And you know that you have to add the 2 plus 4 to get 6. So your final answer will be x to the 6th, because 2 plus 4 is 6, and then you write down the y to the third at the end. Do we get it? Okay. Let me give you one more example using this rule. Let's say you have 2x to the third times 3x to the second. So right here, you could rearrange it. I mean, most of the time, once you get good at this, you'll just be able to get the answer 6x to the 5th. But right now, because we're seeing it for the first time, it'd be good to rearrange it. Let's put the coefficients, the numbers, 2 times 3. Let's put the numbers together, and then bring down the x to the third times x to the second. It is all multiplication, right? From the start, it's really saying 2 times x to the third. Even though it looks like one term, 2x to the third, It is a monomial, but there's really multiplication between it. There's multiplication between the x to the third and the 3, and there's multiplication between the 3 and the x squared. So you could just take the 2, put it there, take the 3, put it there, the x to the third, the x to the second. You could rearrange it however you want with commutative property of multiplication. So anyway, 2 times 3, that really is 6, and x to the third times x to the second, you have the same base. You could add the exponents, it becomes x to the fifth. So your final answer for the 2x to the third times 3x squared is 6x to the fifth. Okay, I did say one more. I lied. I'm going to give you another one. Here we go. So everybody copy this example down. 2x to the seventh, y to the third times 5xy squared. Okay, now remember, there is pure multiplication between every single, like 2 times x to the seventh times y to the third times. There's multiplication everywhere. So you could rearrange these to put them in order. So I'm going to put the coefficients. I'm going to put the 2 and the 5 together. It's going to be 2 times 5 times, now let me put my x's together. There's an x to the seventh, and then it's times x. And then let me put my y's together, times y to the third times y squared. So now I'm able to see my answer. 2 times 5 is 10. Now x to the seventh times x, there's an invisible 1 as an exponent. Even if you have no exponent, it's really like if you had a 1 right there. So you have to add 7 plus 1, and you'll get 8. And y to the third times y to the second, that is y to the fifth. And ladies and gentlemen, that's as hard as rule 1 gets, pretty much. That's it. So the 2 and the 5, those obviously are not the same base, right? If it was 2 times 2, then you could write it as 2 squared, but then again, 2 squared is 4 anyway. But right here, these are actual coefficients. These are numbers. You could actually multiply 2 times 5. That's what simplifying is all about, is doing any math possible. 2 times 5, you could do that. Let's write down 10, right? But the exponents, yeah, we're going to end up adding. Now, I already gave you the reason why the rule exists. X to the seventh, that's really x times x times x, 7 x's, and 1 more x is a total of 8 x's being multiplied together. Y to the third, that's y times y times y, times y times y, that's a total of 5 y's that you're multiplying together. That's your answer. Let's move on to rule number 2. Rule number 2 says, if you have a power to a power, an exponent and then another exponent, multiply the exponents and keep the base. Okay, so right here you have, in parentheses, you have x squared, and then on the outside of the parentheses you have a power of 3. So right here we really do have a power to a power, so we know the shortcut. This rule is really a shortcut, and the shortcut is multiply the exponents. So right here, the answer is really x to the sixth. Now, all these rules, like I said, are shortcuts, because what would we really have to do? Let me explain this right here. In the parentheses, we have the base x squared. So think of this. The base is really x squared, and the exponent is really 3. Okay? So the base is x squared, the power is 3. What does this 3 tell you to do? It tells you to multiply the base with itself 3 times. You guys remember that? So we're going to multiply the base with itself 3 times. So let me just write that out. Since it's in parentheses, I'm going to write it in parentheses. There's my expansion, x squared times x squared times x squared. That is really x squared to the third, right? Now, what is x squared? X squared is really x times x. And x squared is really x times x. And x squared is really x times x. And of course, there is multiplication between these parentheses, so there's multiplication between these pairs of x's. So you really have x times x times x times x times x times x, which is a total of 6. That's why the answer is x to the sixth. Now look at this work. That's ridiculous, right? Like I said, this rule, it didn't come from somebody just making this up. Oh, I'm going to multiply 2 and 3. No. It came from looking at all the work and saying, hey, there's a shortcut. Instead of expanding all of this, I could simply multiply 2 times 3 and get my answer directly, x to the sixth power. So let's see a couple more examples here. So 2 to the third to the second, you could do this many different ways. You could apply the power to a power rule and then rewrite it as what? What's your answer going to be? In exponential form. What's your answer going to be? 2 to the sixth in exponential form. Now, of course, if I don't say exponential form, you want to give the final answer, the simplified answer, which would be 2 times 2 times 2 times 2 times 2 times 2. And then we go through this. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So that's a final actual answer. So I just wanted to show you that it could be done, obviously, without a variable as an exponent, with a number as an exponent. Let's keep going. Another example. How about that? You have a power to a power to a power. You have x to the second, to the fourth, to the third. So what is your final answer?
24?
X to the 24th power. Can't just say 24, that'd be incorrect, right? This is actually x to the 24th power. Again, the rule says when you have a power to a power, multiply the exponents. So 2, 4, power to a power, 8. So you could really rewrite it as x to the 8th, and then power of 3, that'd be 24 total, because 8 times 3 is 24. So a power to a power, you multiply. Now, of course, you could expand it, but that would take a long time. It'd be ugly. So that's why this shortcut was created, so you could just come up with an answer quickly instead of expanding. Quickly. X to the second, to the fifth, to the eighth. What would the answer be? X to the 80. Because 2 times 5 is 10, and then 10 times 8 is 80. So x to the 80. You don't want to just say 80. You want to say x to the 80th power. I think that's good enough for rule 2. Now rule 3, it kind of is coming from rule 2. Let's check out rule 3 here. Yeah, this rule is a lot longer than the other ones. Let's jot it down. It says if you have parentheses, down here you see an example with parentheses right here. If you have parentheses with an exponent on the outside, like right here, the exponent on the outside is 3. And it says, and a monomial. Now, I know you guys, we haven't gone over, maybe we did. A monomial is simply nothing but multiplication. That's actually one term right here, but that's because there is no addition or subtraction. So there is no plus or minus between any of these terms. It's all multiplication. That makes it a monomial. So if we have parentheses with an exponent on the outside and no addition or subtraction on the inside between the terms, then we could distribute the exponent from the outside to each inside exponent. It says, remember rule 2, power to a power you multiply. So it's kind of, I like to call it the distributive property rule, even though it's not actually distributive property. Normally we have like 5 right here and we distribute it to each term on the inside. When you have a power on the outside and a monomial on the inside, you could distribute the exponent to each and every exponent on the inside of the parenthesis. So let me actually show you what that looks like. This 3, I'm going to distribute it to each and every exponent. Now, let me ask you this before I distribute. What is the power on the number 2? What is the power on the number 2? Is there a power right here? So what power is there really? An invisible 1, that's right. So you might as well write the 1 right there. And the power on the x, that's 2. The power on the y is what? What's the power on the y? It's also 1 because there is no exponent there. So when we distribute this outside exponent to each and every exponent on the inside, I need to make sure that those 1s are represented, those invisible 1s. So my answer so far is going to be, when I go 3 times 1, I'm going to get 3. So it's going to be 2 to the 3rd power so far. And then it's going to be x to the what? X to the what? 3 times 2? 6. X to the 6th power. Y to the what? Y to the what? Y to the 3rd power. Okay? And then z to the what? Z to the 15 power. Great. So we simply took that 3 and distributed it to each and every one on the inside. And of course the final answer would be 2 to the 3rd, that's 8. And then x to the 6th, y to the 3rd, z to the 15th. That's the final simplified answer on rule number 3. So let's try another one. I want to make it a little easier. How about this? Parenthesis, 2x to the 3rd power. Jot that down. And what do you guys say the answer is here? Or how about this? What would my first step be? Okay. Distribute the outside exponent 3 to the inside exponents. And I hear you guys say put a 1 on the 2 and a 1 on the x. That's a smart thing to do, so you could actually remember that you're going to be multiplying the outside exponent of 3 times 1 and the outside exponent of 3 times 1. So what do we have as an answer so far? 2 to the third power and x to the third power. Now that is our answer. However, is there anything else that we could do? The 2 to the 3. This right here is really 2 times 2 times 2. So the answer is 6, right? Wrong. 8. It's 8. I know. I'm just checking to see if you guys are awake. 8x to the third. And ladies and gentlemen, that's your answer right there. Okay? Let's try one more. Okay, so write that one down. And what would the final answer be? Anybody?
27 and then x to the 21.
27 and then x to the 21 and then y to the third and z to the 15th. Perfect. Okay, so if you guys are thinking, what? How to get that answer? Let's actually show the work here. There's a power of 1 on the 3. There's a power of 1 on the y. Let's take this outside exponent 3 and distribute it to each and every one. So we really have 3 to the third power, and we have x to the 21 power because 7 times 3 is 21. We have y to the 3 power because 1 times 3 is 3. We have z to the 15th power because 5 times 3 is 15. And now the only other thing that you could do is actually simplify the 3 to the third. That's not 9. 3 to the third is really 3 times 3, which is 9, and then times 3. 9 times 3 is 27. So your final answer is 27x to the 21, y to the third, z to the 15. So this is our final answer right here. And let's just do a quick review here. X to the third times x to the fourth. What's the answer? X to the seventh. Cool. All right. Now, how about 3x to the fourth times 4x to the third? What would that answer be? 12x to the seventh. Okay, cool. How about if I had x to the third to the fourth? What's that answer going to be? X to the 12th. All right, so far so great. What if I had x? How about this? 2x to the third. Yep. Distribute to each, and you will get 2 to the third and x to the third. And the only other thing you could do from there is a 2 to the third. That's really 2 times 2 times 2. 8x to the third will be the final answer right there. Okay? How about 2x to the third, y to the fifth times, not times, but to the third power? What would that answer be? Okay, so some of us are saying the final answer. Some of us are actually distributing this to each and every exponent. And we do get 2 to the third, x to the 9th, and y to the 15th. Okay? So yeah, your final answer is 8 because 2 to the third is 8, x to the 9th, y to the 15th. All right? Cool. I think we got this. However, let's make it more interesting. Check this out. Once again, we do have parentheses here with the exponent on the outside, so I'm going to distribute that outside exponent, the 2, to the 2, the x, and the 3. So what do I get? I get 2 to the second, x to the second, y to the 6th. And now let's do the other one. I'm going to distribute the 2 over here. 2 on the 3, I get 3 to the second, and then x to the 4th, and then y to the 2nd. Perfect. And now we really do have multiplication between all the terms. And what could we do? We could actually do 2 squared. What's 2 squared?
4.
That is 4. And what is 3 squared? 9. 3 squared is 9. Now, notice I put the 4 right here. I want to put the 9 right next to it. Now, keep in mind, we are multiplying on all these. And then I'm going to take the x squared that's above and just bring it down. And I'm going to take the x to the 4th that's above and bring it down. And then I'm going to take the y to the 6th that's above, bring it down, and the y squared that's above and bring it down. And then your final answer, 4 times 9, 36, x to the 6th, y to the 8th. Pretty cool, huh? So right there we had all these rules that we applied together. Okay, so homework is to watch this video. So right here is another final problem here, applying the different rules that we learned today. A power to a power you multiply, you're going to end up with x to the 6th. And then over here, you have to distribute. There's actually 2 invisible ones, so multiply them both, and you'll get 3 squared times x squared. And of course, we can move things around. So we'll put the 3 squared first, the x to the 6th second, and then the x to the 2nd at the end. And of course, 3 squared is 9, and x to the 6th times x to the 2nd is x to the 8th. So final answer is 9x to the 8th. I hope you enjoyed it. Enjoy. Subscribe to my channel. Yes.